Mars, the red planet, has long been a symbol of curiosity and mystery. Its stark, red landscape, devoid of life, beckons humanity with the promise of new frontiers. The allure of this neighboring world has captivated scientists, dreamers, and explorers for generations. But the question persists, could we ever transform this cold, barren world into a thriving, green haven? Our fascination with Mars is rooted in both science and imagination. For decades, we've sent probes, rovers, and orbiters to study its surface, seeking to unlock its secrets. Each mission brings us closer to understanding this enigmatic planet. Yet the ultimate dream is far more ambitious, not just visiting Mars, but making it a second home for humanity. Mars holds a unique position in our solar system. It is the most Earth-like of our neighboring planets, with polar ice caps, seasons, and a day length similar to our own. However, its current state is anything but hospitable. The thin atmosphere, composed mostly of carbon dioxide, offers little protection from harmful solar radiation, and the average surface temperature hovers around a frigid 80 degrees Fahrenheit. So why consider terraforming Mars? The answer lies in humanity's long-term survival. Earth's growing population and the increasing strain on our planet's resources make the prospect of colonizing other worlds increasingly attractive. Mars presents an opportunity for expansion, for building a new home that could serve as a backup in case of catastrophic events on Earth. Moreover, the act of terraforming Mars would mark a monumental achievement in human history. It would showcase our ability to shape and adapt the environment of another planet, pushing the boundaries of science, engineering, and innovation. Historical context. The idea of colonizing Mars is not new. Visionaries like Carl Sagan and Elon Musk have long advocated for humanity becoming a multiplanetary species. The concept of terraforming, though ambitious, has been explored in science fiction and academic research alike. The notion that we could turn Mars into a second Earth has inspired countless studies, debates, and speculative designs. Ethical considerations. Terraforming Mars raises profound ethical questions. Should humanity have the right to alter another planet's environment? What if there is existing microbial life on Mars? These questions would require careful consideration as we ponder the implications of reshaping an entire planet for our own needs. Transforming Mars into a habitable planet involves three major steps: warming the planet, creating a breathable atmosphere, and introducing life. Each of these steps is a monumental challenge that requires advanced technology, innovative thinking, and an understanding of planetary science. Warming the planet. The first step is warming the planet. Mars is currently too cold to support liquid water on its surface. To raise the temperature, scientists have proposed several methods. One idea is to deploy massive orbital mirrors that reflect sunlight onto the surface, effectively increasing the planet's temperature. These mirrors would be positioned to focus sunlight on the polar ice caps, causing them to melt and release carbon dioxide, a potent greenhouse gas. Another method involves releasing greenhouse gases, such as carbon dioxide and methane, to trap heat in the atmosphere. This process would create a positive feedback loop, where the warming atmosphere leads to the release of more gases, further increasing the temperature. Innovative concepts. Beyond traditional methods, some scientists have suggested more radical approaches. For instance, directing asteroids to impact Mars could release energy and gases, contributing to the warming process. This approach, though extreme, demonstrates the creative thinking required to tackle the challenges of terraforming. Once Mars is warmer, the next step is to build a thicker, more breathable atmosphere. The current Martian atmosphere is only about 1% as dense as Earth's and is composed mostly of carbon dioxide. To make it suitable for human life, we need to increase the atmospheric pressure and introduce oxygen, thickening the atmosphere. One proposed method for thickening the atmosphere is to stimulate artificial volcanic activity. By triggering volcanic eruptions, we could release gases trapped beneath the surface, including water vapor, carbon dioxide, and nitrogen, key components for a breathable atmosphere. These gases would help build a more substantial atmosphere, capable of supporting life. Another idea is to import ammonia-rich asteroids and comets. When these celestial bodies crash into Mars, they would release ammonia, a potent greenhouse gas, which would contribute to warming the planet and adding nitrogen to the atmosphere. Advanced technology plays a crucial role in this step. Machines like MOXIE, Mars Oxygen Resource Utilization Experiment, are designed to convert carbon dioxide into oxygen. Scaling up such technology could provide the oxygen necessary for humans to breathe and for other life forms to thrive. Artificial magnetic field. One significant challenge in building a sustainable atmosphere is Mars' lack of a magnetic field. Without this protective shield, the planet is vulnerable to solar wind, which can strip away the atmosphere. To address this, scientists have proposed creating an artificial magnetic field, perhaps by placing a large magnetic shield in orbit around Mars. This shield would deflect solar wind, protecting the atmosphere and surface from radiation. With a thicker atmosphere and warmer temperatures, the final step is to introduce life to Mars. This process, known as ecological engineering, involves creating an ecosystem that can sustain itself and support human life. Extremophiles. The first organisms to be introduced would likely be extremophiles, microorganisms that can survive in extreme conditions. These hardy organisms could kickstart the ecological chain, preparing the environment for more complex life forms. Their presence would begin the process of transforming Mars into a more Earth-like environment. Plant life. As the ecosystem develops, plants could be introduced. Plants play a crucial role in converting carbon dioxide into oxygen through photosynthesis, further enriching the atmosphere. The introduction of plant life would not only help create a breathable atmosphere, but also contribute to soil formation, enabling the growth of more diverse vegetation. Biodiversity. Over time, a diverse and self-sustaining ecosystem could emerge. This ecosystem would support human settlements, providing food, oxygen, and other essential resources. The development of biodiversity on Mars would mark a significant milestone in the terraforming process, signaling that the planet is on its way to becoming a habitable world. Terraforming Mars is an unprecedented challenge, and numerous unknowns could arise. The planet's unique environment presents a host of potential obstacles that must be addressed. Radiation protection. Without a magnetic field, Mars' surface is exposed to high levels of radiation. Developing effective radiation protection is crucial for the survival of both humans and introduced life forms. Solutions include constructing habitats underground or using materials that shield against radiation. Ecological balance. Introducing life to Mars must be done carefully to avoid disrupting the planet's potential native ecosystems. The balance of introduced species, their impact on the environment, and the interactions between different life forms must be monitored and managed to ensure the long-term success of the terraforming project. Technological resilience. The technology used in the terraforming process must be resilient and adaptable. From maintaining atmospheric generators to managing artificial magnetic fields, the systems put in place must be capable of operating in Mars' harsh conditions and evolving as new challenges arise. Terraforming Mars is not just about survival, it's about securing humanity's place in the cosmos. It represents a bold step toward becoming a multiplanetary species, ensuring that humanity's legacy continues regardless of what happens on Earth. A new frontier. The process of transforming Mars would take centuries, if not millennia, and require the collective effort of generations. It's a vision that transcends individual lifetimes, calling on humanity to think and act on a cosmic scale. Establishing a thriving green Mars would be a testament to human ingenuity, resilience, and determination. The future of exploration. Terraforming Mars would pave the way for future interplanetary exploration. The lessons learned and technologies developed could be applied to other celestial bodies, expanding humanity's reach throughout the solar system and beyond. This endeavor would mark the beginning of a new era in human history, an era where we are no longer bound to a single planet, but are free to explore and inhabit the stars. A legacy of hope. As we stand on the brink of this monumental endeavor, the question remains, are we ready to embrace the challenge? The potential rewards are immense. A thriving green Mars serving as a beacon of human ingenuity and determination. It's a dream that inspires, a challenge that tests our limits, and an opportunity to redefine what it means to be human. Terraforming Mars is more than a scientific endeavor. It's a declaration of hope, a belief in humanity's ability to adapt, innovate, and thrive. The journey to transform the Red Planet into a new Earth will be long and arduous, but the legacy it leaves behind will be one of the greatest achievements in the history of our species.